Among all the concepts in trigonometry, the one that requires a skill is definitely proving trigonometric identities. And mind you, skill can always be developed with constant practice. In this video, we are going to see one such question that requires a different approach. Hey there, welcome to Leap, where you learn once and remember forever. Let's begin to prove this problem and make it as easy as possible. Let's see what's the question. We are required to prove that cos theta minus sin theta plus 1 divided by cos theta plus sin theta minus 1 equals cosecant theta plus cot theta. Now, the usual way in which we approach this concept would be picking the side which is complex. So here you can see the left hand side identity is already in cosine form, which is the simplest form, but the right hand side is in the form of cosecant theta and cot theta. But when you try to solve the right hand side of the equation, you will not be able to reach the left hand side of the equation. Let's try it. So the right hand side of the given identity is cosecant theta plus cot theta. So we know that cosecant theta can be written as 1 over sin theta, because it is the reciprocal of sin theta, and cot theta can be written as cos theta over sin theta. So here you can see that the denominator is same, so I can rewrite this as 1 plus cos theta over sin theta. Now this has no connection to whatever is given in the left hand side, so this does not prove anything. So what do we do in that case? Let's start from the left hand side now. Now when you look at the left hand side, it is more complicated than the right hand side because it has fractions in it. But still, the ratios are much simpler on the left hand side. So the only way to solve this is to try and make this simple ratio that you have in the left hand side to a complex ratio that is in the right hand side. So you can see you have cosecant and cot on the right hand side. You have to think of what can you do on the left hand side to bring cosecant and cot. So to begin with, let's write down the left hand side of the identity. So your left hand side of the identity is cos theta minus sin theta plus 1 divided by cos theta plus sin theta minus 1. Alright, now when you look at the numerator and the denominator, they have no connections to cosecant and cot. So let's start with the numerator alone first. How can you make these terms in the numerator relevant to cosecant and cot? So what can you do to cos theta to get either cosecant or cot? So you can either divide them with sine or cos. Those are the most simplest values, right? So let's try doing it with sine first. So cos theta divided by sine theta is going to give me cot theta. Sine theta divided by sine theta is 1. 1 divided by sine theta is cosecant theta. So we got cosecant and cot when we simplified this. Same goes with the denominator as well. But if you try to divide them with cos theta, what happens is cos theta over cos theta gives 1. Sin theta over cos theta gives tan theta, which is not required. And 1 over cos theta gives secant theta, which is also not required. So the best way is to divide the numerator and the denominator by sin theta. So dividing the numerator and denominator by sin theta. Now when you divide, you will divide each term by sin theta. So let's do it together. So cos theta divided by sin theta minus sin theta divided by sin theta plus 1 divided by sin theta. Now similarly, when you divide the denominator by sin theta, you get cos theta divided by sin theta plus sin theta divided by sin theta minus 1 divided by sin theta. Now let's write the equivalent ratio values. So cos divided by sin is cot theta. minus sine over sine is 1 plus 1 over sine is cosecant theta divided by cos over sine is cot theta plus sine over sine is 1 minus 1 over sine is again cosecant theta. So this is what you arrive at. Now I'm going to try and put the ratios together and the constant at the end. That gives me cot theta plus cosecant theta minus 1 divided by cot theta minus cosecant theta plus 1. Now here, in order to proceed further, you will have to use a trigonometric identity that is relevant to this. So you have 3 different trigonometric identities, the basic 3 identities. Sine squared plus cos squared is 1, cosecant squared minus cot squared is 1, secant squared minus tan squared is 1. Now, you don't have squares here, but you do have a 1. So this 1 can be used as the identity. So this 1 can be replaced with the identity that has cosecant and cot. What is the identity again? So the identity is cosecant squared theta minus cot squared theta equals 1. So this 1 is going to be replaced with this identity. So let's try and do that. Now don't use this identity and replace both the ones in the numerator and the denominator. It is always good to keep the denominator simple. So substitute in the numerator. So what happens is cot theta plus cosecant theta minus, whenever there is a minus and you're going to introduce a binomial, brackets are very important. So open the brackets and you have cosecant squared theta minus cot squared theta divided by cot theta minus cosecant theta plus 1. So when we try to solve this, you can see that this cosecant squared theta minus cot squared theta looks like an identity, an algebraic identity. What is that identity again? A squared minus b squared equals a plus b times a minus b, where your a is your cosecant theta, b is your cot theta. So in order to open that up, what we do is, since you have cosecant as a and cot as b, you can rearrange this and write. So when you rearrange and write, that means instead of writing a plus b, you can write b plus a. Same thing. So cot plus cosec or cosec plus cot doesn't make a difference. So we can write that as cosecant theta plus cot theta. Let's put this in brackets so visualization is better. So using the algebraic identity, you get, as usual, put the negative and the brackets on. So you get cosecant theta minus cot theta and cosecant theta plus cot theta divided by cot theta minus cosecant theta plus 1. Now you can see that this is one term and this entirety is a term. So what is common in this term and this whole term? So you can see cosecant plus cot and cosecant plus cot here. They both are common, right? Take that common term outside. So when I take this common out and I open the brackets, this gets replaced with 1. And this negative sign is as it is. Now from these two products, you have cosecant theta plus cot theta taken out already and you're left with this. So that can be written as cosecant theta minus cot theta times 1, because this term is already taken out as common. This is just like how you take out a common in a minus ab. So how do you take out a common here? So when you take out a, that means it gets replaced with 1, because a times 1 gives you a. Same way, negative sign as it is. A is already taken out, so that is replaced with 1. 1 times b, so that is b itself, right? Now proceeding further, Your denominator is as it is, no change. So cot theta minus cosecant theta plus 1. Let's simplify this further. The first bracketed term is going to be as it is, cosecant theta plus cot theta. Now this term can be simplified. That can be written as 1 minus. So this is a binomial again. So when there is a negative sign, you multiply the negative sign to the ones inside. So negative cosecant theta, and then negative becomes positive cot theta. Anything times 1 is anything, so that remains as it is, and your denominator will remain as it is. Now, when you observe this fraction, you can see that the denominator, cot theta minus cosecant theta plus 1, the trinomial, is the same as this trinomial. So you can see positive cot, negative cosecant, and positive 1. So these two terms are one and the same, so I can cancel them out. This gets cancelled, and I'm left with my right hand side, which is cosecant theta plus cot theta. We have reached our RHS. So this is how you will solve it. There is a similar question of this sort in the example as well, which is this question. You can try solving this question, and the identity that you will replace here is going to be secant squared theta minus tan squared theta equals to 1. So in the previous question, we used cosecant squared minus cot squared. That is the only difference, but rest all steps are similar to this question. You can try solving this question. I hope you are now able to understand why we had to approach this problem differently than the regular way. Thank you so much for watching. If you like this video, please give a thumbs up. And if you have any questions or doubts, please leave them in the comment section. I'll get back to you shortly. And please follow LEAP to learn more and make math AEAP. Thank you.